So in this problem, we need to verify the following. Let us begin. So here we will start from the left hand side, but before that, let's try to understand the numerator. So here we have the first term, which is given by 1 times 2 squared, added to the second term that's given by 2 times 3 squared. So this keeps on continuing, and then we reach the nth term, which is given by n multiplied to n plus 1 whole square. So if we consider this to be the sum as 1, then this is going to be our nth term of the series. Now to find out the sum, all we have to do is take the nth term. So here, let us suppose that let Tn represent the nth term of the sequence given by n times n minus n times 1 whole square. So all we have to do is find out Tk, where k goes from 1 to n, summation of tk. So that's going to give us the sum of the series. In other words, all we have to do is take the summation of tk. So we have to replace the index n with k to get k multiplied to k plus 1 whole square, where k runs from 1 to n. Let's further simplify this. This is simply going to be the summation of, so when we open it up, we get k cubed added to 2k squared added to k. Fine. Now what we'll do, we will separate the summation. So we have k running from 1 to n. The first summation would be summation k going from 1 to n. We have k cubed added to 2 times the summation k squared, where we have k going from 1 to n, added to summation of k with k running from 1 to n. So this is going to be equals to, now the first summation is simply the sum of cubes of the first n terms. Now that means here we have a standard formula given by n squared multiplied to n plus 1 whole squared divided by 4, added to 2 times summation of k squared is simply sum of the squares of the first n terms of a natural n terms. That's going to give us n multiplied to n plus 1 times to n plus 1 whole divided by 6, added to now summation of k, so that's n times n plus 1 whole divided by 2. Fine. So now from each of the terms, we're going to take n multiplied to n plus 1 over 2 as the common factor. Now that means this was going to get multiplied to n times n plus 1 over 2, added to 2 times 2n plus 1 divided by 3, added to 1. Okay, now what we'll do, we have n times n plus 1 divided by 2. We're going to combine the 3 terms inside the parentheses, so we have a common denominator of 6. So in the numerator, we're now going to get 3n squared plus 3n, added to, we have 8n added to 4 plus 6. So let's further simplify. We're going to get n times n plus 1 divided by 2 multiplied to, so 3n squared added to, so 8n plus 3n, that's going to be 11n added to 10 divided by 6. Okay, so furthermore, we can factorize 3n squared plus 11n plus 10. So that's going to give us 3n plus 5 multiplied to n plus 2 whole divided by 12. Okay, so this is the sum of the series 1 times 2 squared plus 2 times 3 squared added all the way up to n times n plus 1 whole squared. Now let's come to the denominator part. So here we have 1 squared times 2 added to 2 squared times 3 plus all the way up to the nth term, which is n squared times n plus 1. Now we're going to assume that this is the sum as 2. We have 1 squared times 2 added to 2 squared times 3 all the way up to n squared times n plus 1. So here this is going to be the nth term. So let's call it the nth term of the series t prime n, given by n squared times n plus 1. Now in order to find out the sum as 2, all we have to do is take the summation of the nth term t prime k, where k runs from 1 to n. Okay, so this is now going to give us, we have summation k equals to 1 all the way up to n. Now n squared times n plus 1, this is simply n cubed plus n squared. So what we'll have, we'll get k cube plus k squared. We have replaced the index n with k. Okay, now this is going to give us summation k cube added to summation k squared, where the index k runs from 1 to n in each of the two summation. Now, summation of k cube, that is simply sum of the cubes, which just gives us n squared added multiplied to n plus 1 whole squared over 4. Added to, we have n times n plus 1 multiplied to 2n plus 1 whole divided by 6. Now from each of the two terms, we can take n times n plus 1 over 2 as the common factor. So we have multiplied to it n times n plus 1 over 2. Added to 2n plus 1 divided by 3. Right, so this is going to give us n times n plus 1 whole divided by 2 multiplied to n squared plus n over 2 added to 2n plus 1 over 3. We're going to combine the two terms within the parentheses. So we have n multiplied to n plus 1 divided by 2. So we have a common denominator of 6. So in the numerator, we have 3n squared plus 3n added to 4n plus 2, which now gives us n times n plus 1 over 2 multiplied to 3n squared plus 7n plus 2 whole divided by 6. Furthermore, we can factorize 3n squared plus 7n plus 2. So we will get n times n plus 1 multiplied to 3n plus 1 multiplied to n plus 2 whole divided by 12. So this is the sum S2. Now what we'll do, we'll take the ratio. So initially we obtained the sum S1 that came out to be n times n plus 1 times 3n plus 5 times n plus 2 over 12. And we're going to divide it with S2. So when we divide the sum S1 with S2, so all the common factors get factored out, and that leaves us with 3n plus 5 divided by 3n plus 1. And this is what we were needed to verify. So we have verified that the ratio of the two sums of the series, where the series is given by, let's go to a problem, the following series, that's ratio comes out to be 3n plus 5 over 3n plus